Okay, so we're going to go over a quick example on calculating z-scores and understanding relative position. Z-score, remember, it basically tells you how many standard deviations away your value is from the mean. That's what a z-score tells you. The formula for that is that it's equal to your value, x, minus the mean. So it's the difference between your value and the mean divided by standard deviation. So in essence, it tells you how many standard deviations you are away from the mean. So if you're given this situation where Mario's weekly poker winnings has a mean of $353 a week and a standard deviation of 67, last week he won 185. How many standard deviations from the mean is that? So basically you're being asked what the z-score is. How many standard deviations away from the mean is that? Not really looking for relative position like a negative or a positive, just wanting how many. So it's a different than z-score, but the calculation is the same. So there's a couple of different ways to approach this problem actually. You can have this formula in your head, is understanding that relative position is your value minus the mean divided by standard deviation. And then there's another way. Let's do this way first. So if the mean is $353 and his standard deviation was $67, and last week he won $185, the z-score, right, the relative position would just be 185 minus the 353, which is his average, divided by the standard deviation, 67. So the z-score would be, calculator crunch, right? 185 minus 353, that gives you a difference of 168, but it's negative. Divide that by 67, and the z-score would be negative 2.51, 507, blah, blah, blah. So about negative 2.5. So relatively, that's 2.5 standard deviations below the mean. So to answer the question, how many standard deviations from the mean is that? You could say 2.5 standard deviations. And then to be more specific, maybe 2.5 standard deviations below. So 2.5 standard deviations below the mean. Or you can say the z-score is negative 2.51, which is saying the same idea. Now there's another way that you can approach this problem. You could just say, okay, well, his average is 353. I want to get to 185, right, from 353. So how many standard deviations is that? Well, I know it's below it, so I can just subtract 67 from 353 to get 286. And that would be one standard deviation away. And then if I subtract 67 again, that would be 2 standard deviations away. That's 219. And now I'm between 219 and I got to get to 185. I'm still not there. If I subtract 67 again, you get 152, and that's 3 standard deviations away. So you could say, okay, well, I know my value is 185, and I know it's between these two values of 219 and 152. So I know it's going to be between 2 and 3 standard deviations. So I got to think, well, 185 equals how many 67s? So 67, how many of those, right? How many of those subtracted away from 353? So 185 equals 353 minus 67x, some value, like how many times do I need to subtract 67 from 353 to get 185? So you could think about it like this and then algebraically solve this problem. You end up getting 2.5 or 2.51. That's how many times you have to subtract 67 from 353 to get 185. So you get the same answer, but you approach it a different way. It all depends on how you're thinking about this problem. But this is a good question to understand how to interpret z-scores, what they mean. They tell you how many standard deviations you are away from a value, and then calculating z-scores is very easy if you have the formula. And that's all I got for that problem.